Hello everyone, hopefully you have your notes in front of you. I'm going to do a couple of examples on a one-sample z-test for population mean. Here's the question. Notice that I did make one small change. It wasn't plus minus, it was the standard deviation was 135, so make a note of that on your paper. So let's see. The GRE reported a average score for students of 558 with a standard deviation of 135. We're selecting a sample of 100 participants at an elite private school. Our hypothesis, or we hypothesize, that students at this score would score higher than the national average, and we want to test this at the 5% level. So let's make a list of the parameters that we know. The GRE is reporting that the mean score is 558 with a standard deviation of 135. From our sample, we got a sample mean of 585. And we tested 100 samples, 100 participants, and we are testing at the alpha level of 5%. So these are all the parameters that we know. Next up, we're going to write our hypothesis. So our null hypothesis is that mu is equal to the national average, 558. The alternate hypothesis for our private school would be that mu is greater than 558. We think the private school students are going to do better than the national average. So here's your null, and here's your alternate. Next up, we need to test our assumptions. First, it says it was a sample, so we must assume, it didn't say what kind of sample, so we're going to assume that it's a simple random sample. Large sample size. Tells us that normality is assumed, so normality is assumed. And sigma is known. Okay, so based upon those three conditions, those three assumptions, we can now name the test that we're going to use. So the test that we're going to be used is a one sample z-test for the mean. Okay, next up, we need to get our test statistic. So our test statistic, the formula we're going to use is the z-score. Z-test statistic is going to equal the sample mean, 585, minus the population mean, 558, divided by the standard deviation of 135, divided by the square root of the sample size, 100. Let your calculator do the work for you, and it will provide you with a test statistic of 2. So if we draw that on our normal curve, and we know that the mean is right there, so 558, with a z-score of 2, so 2 standard deviations greater. So this is the area we're looking at. So right off the bat, I'm suspecting that this is going to be a fairly small probability. Now we can go to our calculator again, and we can let our calculator calculate the probability for us using a normal distribution, and we wind up getting a probability, a p-value, of 0.0228. Now that probability is obviously smaller than the 5% alpha, right? So this was our 6th step there. So over here, since our p-value is so small, we need to make a decision, and our decision would be that we are going to reject the null because our p-value is so small, and then the final thing is to state your conclusion. So your conclusion should say, since p is less than alpha, we, or I, reject the null hypothesis. There is sufficient evidence to conclude that the private school students scored higher on the GRE than the national average. And that's it. So those are your steps. So remember the steps from the video. Parameter, this is P. State your hypothesis, that's H. Test your assumptions, that's N. Name your test. Calculate your test statistic. Obtain your p-value. Make a decision. And then state your conclusion. So the phantoms. Alright, so now I'll do one more for you. So here's our next example. An auto manufacturer recommends that any purchase of one of his new cars brings it in to the dealer for a 3,000-mile checkup. The company wants to know whether the true mileage at this initial servicing differs from 3,000. A random sample of 50 recent purchases resulted in an average of 3208. Past history has indicated the population standard deviation is 273 miles. Does this data strongly suggest that the true average mileage for this checkup is something other, there's a key phrase there, something other than the numbers recommended by the company? So first off, let's state what we know. So we know that mu is 3,000. They did a random sample of 50, and they got an X bar of 3208. And the population standard deviation was 273. They don't provide an alpha for us. They just ask you, does this data strongly suggest? So we're not going to have an alpha. We're just going to have to figure out the p-value is and make a decision based off of that. So our null is that mu equals 3,000. This is what the manufacturer recommends. Our alternate is that mu is not equal to 3,000. This is where it says something other, or that the initial servicing differs. It doesn't say that it's more, it just says that it differs. So we just use not equal. Test our assumptions. Let's see, it says it's a random, so SRS. That part was given. There's a large sample. Right, so normality is assured. And sigma is known. Right, based on those conditions and assumptions, we can say that we are going to perform a one sample z-test for the mean. Right, next up we're going to calculate our z-statistic. So z is going to equal 3208 minus 3,000 divided by 273 divided by the square root of 50. And we let our calculator do the work for us, and we get a z-statistic of 5.39. Now that's a big z-score, so that means it's pretty far away from the mean. So if you picture what this is looking like, here's our mean of 3,000. And with that big of a z, we're looking at way out here and also way out here, right? Because it's both sides. It's both sides because it's not equal instead of being greater than or less than. So we're looking at both sides. Again, use the calculator and use the norm CDF or your test statistic and obtain a p-value. And I'll show you, if you're not sure how to do this, This is something we're going to be talking about in class. We're going to get a p-value, in this case, of basically 0. It's something really small because it's 5 standard deviations away. We need to make a decision. Well, with a p-value of that small, we are obviously going to reject the null. And so finally, we just need to state the conclusion in context. So we can say that since the t-value is essentially 0, we reject the null. With a p-value of that small, we can say there is strong evidence to suggest that the true average mileage for the initial servicing differs from the manufacturer's recommendation. My pen is not working well for me tonight. And that's it. Alright, so you have 2 examples. Hopefully that cleared some things up for you. And that's the basics of what you want to be following and what you want to be doing as you are doing these tests. So have a good evening, and I will see you tomorrow.